Today we're going to walk through an example of how to use Stream's archiving capability as well as the replayability. And we're going to use specifically Azure Blob, and then to kind of prove it out and show how this all flows through. Of course, we'll use Stream, and then Humio as well. Now, let's spend a couple minutes talking about like why this is important to begin with. When we talk about data retention requirements, we want to try to use storage that is designed for that, and cheaper than perhaps using our systems of analysis as the kind of data lake store. Specifically, maybe we have a large Splunk instance. We need to keep our logs for 3 years, and we're just throwing everything into Splunk. Well, that would be a very expensive way to do it, especially if most of our searches are really only, I don't know, 6 months in the past at most. And maybe every once in a while we need to search that historical data, maybe for audit purposes or investigative purposes. Now, what would be a more ideal way to do this would be to send everything to object storage. In this case, we'll be talking about Azure Blob, and then send select data or reduced data or cleaned up data to our analysis platform. And that way we're being a little bit more efficient with our expensive analytics license that usually is charged by ingest or maybe by workload. And with Stream, we still have the ability to call back that data in object storage, whether that be, again, for audit purposes or retention policies or any kind of investigative issue, play that back through Stream, and then send it, of course, again, to our system of analysis for the further investigation. So to set the stage of, again, kind of the pieces that we're using here, we'll be using Stream, of course, Azure Blob as the object storage, and Humio as the kind of analytics platform. So let's get started with kind of what the configuration looks like. So in this case, we're using sample data that we're generating constantly. You can find it under data gen. And in this case, it's the syslog. So I can open the syslog source, click on live data, and of course we can see that what we're generating. So it'd be this raw string, and Stream understands syslog natively, so we're breaking out all these cool header information into their own fields. Likewise, for destinations, we have our Azure Blob configured, which let's go ahead and walk through what that configuration looks like. So I've got my container name, which is the object storage, the Azure storage account object. You can see the container here, Cribl. And then telling it that we want this data stored in JSON. We've got our authentication, of course. And then we should spend a few minutes talking about partitioning expression. Now, what this means is, how do we want Stream to store the data in object storage so that we can be really efficient when we go to search that object storage later to pull back specific sets of data? So in this case, think of this as a file structure. So in this case, we want to use some time parameters, and then from our event itself, the timestamp values and the host. So we could even click on advanced mode here and kind of get an idea of what this looks like, right? So in front of this, because of that prefix value, we'll see demo, and then this output. And I can actually show you that that's being followed here in Blob. If I click to the Cribl container, you'll see my prefix value here, demo, and then dates, the year, month, day, host, right? Okay. We've got Humio set up, so we are sending everything straight to Humio as well. And you can kind of see we're doing some things to the data because it is more convenient to look at it this way. Maybe it's more efficient. But in any case, we've done some chopping up of the data and the fields in it and format it into JSON. Okay. Now, if we look at what our routing table looks like, pretty simple here. You can see that at the very top, we've got an archive to blob. Our filter is just the input ID of that data gen that we're using. And we're sending it to a pipeline called syslog blob. And we can go into what that looks like. But essentially what we're doing is, since we understand syslog natively, we've got all those fields broken out and piecing it back together in a JSON message. Of course, we're sending data out to Azure, as the route kind of implies. And importantly, we've got the final flag here set to no. So what this means is any data that fits this filter will go through this route, and instead of being consumed by this route, it's going to pass that data along down the rest of the routes. And you can see, if I expand the second route, that we have the exact same filter, with the exception of adding that replay not equal true. And I'll explain what that is in a moment. So in this case, it's the same data set. We're sending it through a different pipeline to do something different. And then we're also sending it out to the Humio output. Okay. Now, when we do a replay, we want to treat it a little bit differently because we don't want to archive. We don't want to archive data that has been replayed again because it's already there in archive. So I have another route here basically saying if replay equals true, go ahead and send it to a different pipeline and back out to Humio, because that's the whole purpose, right? We want to be able to selectively pull back sets of data from our archive, process it in the way that we need to process it, and then send it to our system of analysis. Okay, let's take a quick look at our pipelines. So again, our archive to blob pipeline, we probably don't want to do too much here because the whole point is that we want to be able to prove that we can send, that we have a unedited full copy of data in archive. So in this case, let's load up a sample. So this is the syslog sample that we've been looking at. If I click the Out tab, all we're doing is kind of throwing away these extraneous fields, making sure that we keep raw, and then that's it. We're passing it along to Azure. Now, if you go look at the other filters or the other pipelines, so now that we've sent off to archive, we now want to send everything to Humio as well. What we're going to do here is basically just convert this raw syslog message to a JSON object. So if I click the Out, you can see, again, kind of gotten rid of these extraneous fields and put them inside of a JSON object instead. Okay. Now, for the last route, when we have done a replay job and we've collected the data that we need to for, again, audit purposes or what have you, we want to treat it differently. So for the Humio replay pipeline, we needed to use a different sample, the replay sample here. This is what the replay sample will look like when it comes into, when we go to collect it. Again, we've kind of preserved that raw, haven't done any change to it. You notice that there's a new field here called replay equals true, just to signify that, yes, this is replayed data, not original fresh data. If I click the out, you'll see that I have converted it into JSON just to make it easier for Humio to understand. But you'll notice a key difference here. I've kept a field named raw. So all we're doing is shoving that original raw message from the collection job, and we're putting it into a JSON object with the field of raw. Okay. All right. So let's see how this all pieces together. So right now we are generating our sample syslog data. I can come into Humio within the last 15 minutes, do a search, and I can see kind of that JSON format we talked about and the fields that we placed in here. You'll notice, your typical headers you'd expect are fields, severity, facility, the actual message, the timestamp, right? So all looks fairly normal. Now, I can go into Azure and I can say, okay, let's take a look at the data here as well. So today's the 29th, and we can see all our different host names we've got here. Now, let's just pick on this one because it's the first one. And let's see that we have this data in Humio. Okay, so it's all the same message. Again, it's just a data generator. We're changing the timestamps, as you can see, but not the raw, not the actual data. So it all looks very repetitive and similar. So this is data that's coming from the data gen through stream to Humio. That same data is being split off to Azure with the _raw field preserved. Now let's say I want to collect that data from Azure. So let's walk through that. If I go to sources, you'll notice I have collectors. So this is where I can actually reach into my object storage, grab or search for some subset of data, a rudimentary search, and then actually consume that data back through stream and out to Humio in this case. So when we configure this, it's actually really easy, especially if you've got a object storage destination already configured. I can actually use the drop-down to auto-populate from that destination. So I didn't have to do much work here. I did, of course, have to tell Stream what the partitioning path looks like, and this should be very similar to what I showed before. I've got the demo, top level, folder name, along with year, month, day, and host. Okay. So if I come over here and click Run, I've got a bunch of options here. So the different modes here, basically I can run a preview, which will, if I ran a preview now, it'll show me all the events it's finding within my object storage. I can save this as a sample file. I kind of just look to make sure that the data that I'm collecting is correct. And that's it. It won't be consumed. Now, if I click Discovery, I won't get the preview of the actual events, but I will see details of what's in that object storage. So if I click this latest ad hoc run link, it kind of opens up a field or a window of objects and statistics of what it's discovered. Finally, if I click full run, it will, based on my filter and my time range, it will grab that data from Azure Blob and actually bring it back into Stream. Now, because of the partitioning expression that we've laid out, I can use that partitioning expression to filter the data that I am reaching into Azure Blob and grabbing. Really easy example here is I can set host equal to that host name that we're picking on. So because there is a partitioning expression where we have host as part of the file structure, we can use it as a filter when we go to do our collector replay. So here we see that same host name, and again, because it's in our partitioning expression, we can use that as a filter for grabbing data from object storage. So let's go ahead and just say anything from today and click run. Now, depending on how much data is in that that filter, that you chose, this could take a little bit of time. This could be very quick. In this case, it should be very quick. And we can see here that it took 3 seconds. It found 25 events, it collected 25 events, and it's finished. So perfect. Now we can actually see in Humio how this is showing up. So let's do, I don't know, let's do today or 15 minutes. Okay. So remember, we only ran that replay for this one sample or this one host, and we can kind of see there's some variation here. So if we focus on just these top 2 events, you can see that the top line is what we'd expect. This is the data that we generated in stream and sent straight to Humio. We talked about how we broke out those fields, put them into a JSON object. We've got our message field. And yeah, so that's what we'd expect. Now underneath it is the event that we grabbed from Azure. And you can tell because there's the raw field where we've preserved the original raw message and with no edits or changes. And at the end here, you'll see a field called replay equal true. So that's how we know that we successfully did a collection job in Azure Blob, replayed that back through stream, and sent it into Humio. Now, a couple best practices with this, and then we'll call it for today. When we're talking about partition expression, we want to be a little careful when it comes to cardinality. If we choose values in our partitioning expression that there could be a significant amount of, we could run into issues like too many files open. We could hit that limit on the worker nodes of how many files are allowed to be open. If the cardinality is too low, what ends up happening is we have files there'll be bigger files written to object storage. They'll take longer to compress. And when we go to do a collection job, our partitioning expression may not be granular enough and cause, we're pulling a lot more data than we actually need, which could run up egress charges and, generally just be less efficient in terms of how much resources we have to throw at pulling data down, and then maybe we only need a subset of that because we didn't do a good job partitioning. If you need more details with that or want to get really technical and dig into it, I'd highly encourage reaching out to us in our community Slack or reaching out to your account team if you have one. Second best practice would be, be friendly to the people who are doing the searches and users of the analytics tool. Try to partition on fields that are commonly searched. Of course, don't go overboard, as we kind of talked about with the previous point. But it makes it really easy to kind of partition that data in a way that makes sense based on how people use the data. And finally, when setting up a stream to do replay jobs or collection jobs, configure a dedicated worker node or worker group for this. Uh, we wouldn't recommend doing this on a production kind of worker group that is processing live data. Um, because the worker groups, when we configure a collection job and schedule it to run, resources are needed. Worker processes have to go, grab that data, pull it back down, and process it. Right. So, depending on circumstances, that could have impact on live production data. So, again, just word of advice: definitely configure a separate, dedicated worker group for this process. Again, if you have any questions on any of this, definitely feel free to hit the community Slack, reach out to your local resources, and thanks for watching.